Good day, students. Welcome to mathgotstuff.com. In this clip, we're going to be going over section 13.6a of our Algebra 2 virtual text. We're going to be looking at how to apply the properties of logarithms. Before we get started, we're going to do a real quick review on some properties of logarithms that will be guiding our problem solving process. Okay, so a real quick review on the properties of logarithms. Now, the first one that you want to remember has to do with the product property. If you have the sum of two logarithms, let's say log base b of x plus log base b of y, this can be written as the logarithm of the product of the logarithmic arguments x, y. Okay? So just remember that when you're adding logs, it's the same thing as multiplying the logarithmic arguments as long as the bases are identical. Okay, so if you have log base b of x minus log base b of y, we're going to apply the quotient property in this case. You have log base b of the logarithm that comes first, x, that will be the numerator, minus, this minus is division, divided by the logarithm that comes next, y. Okay? So there goes the quotient property. And then we have the third property of logarithms, and that is the power property of logarithms. Okay? So let's say you have a log base b of x. This can be written as, you just power up the coefficient, that becomes the power of the logarithmic argument, and you will have log base b of x to the a. Alright? So this power property of logarithms is basically a property that helps you clear out coefficients of logarithms in order to condense them, as you'll be seeing in the presentation today. Okay? So these are the properties: log base b, where you have a numerical base for your logarithms. Now, what if your base is the number, the irrational number e? Okay, so if you have log base e, in that case, you're going to be looking at the natural logarithm. So let's take a look at how we can extend these ideas to natural logarithms. So if you have the natural logarithm of x plus the natural logarithm of y, the same formula applies. It's simply the natural logarithm of x times y. And then for 5, if you have the natural logarithm of x minus the natural logarithm of y, it's just log base e. The same principle applies, the natural logarithm of x over y. And then, of course, if you have a coefficient for your natural logarithm, let's say a ln x, this can also be written as the natural logarithm of x raised to the a power, a consequence of powering up your logarithmic coefficient, the coefficient of your logarithmic term. Okay, so these are the properties that we're going to be using to condense the logarithmic expressions that we are going to be working on in this presentation. So the instructions for us we're to condense the given logarithms. Okay, condense the given logs. Alright, so problem 1. Let's say we have log base 3 of 5 plus log base 3 of 2. Okay, so let's go ahead and condense it. So our solution is as follows. Starting with log base 3 of 5 plus log base 3 of 2, we just have to remember the rules. Okay, when you have the sum of logarithms, what you're looking at is the product of the numbers, the logarithmic arguments. Okay, so think about log and the real world. So in the log world, when you have plus, in the regular non-logarithmic world, we're looking at the product of the logarithmic arguments. So this plus right here is going to become a product of the logarithmic arguments, which is 5 and 2. Okay, so this is going to become as a combined log base 3 of 5, and then this plus becomes times 2. All right, and then we can simplify this further. This becomes log base 3 of 10, and that's your final answer. All right, let's take a look at another example, question 2. What if we have 2 log base 4 of x plus 3 log base 4 of y? So we see the difference between these two, other than the fact that the logarithmic arguments are variables. You notice that we have coefficients present. So we have 2 and a 3, and those are present. So that has to be taken care of before we can condense our logarithms using the appropriate um, properties. Okay, so we have log base 2 log base 4 of x plus 3 log base 4 of y. So we're going to start by clearing out these coefficients. To accomplish that, we're going to use the power property, so we can power up the coefficients. So power that up and power that up. And that yields log base 4 of x squared, the coefficient becomes a power, plus log base 4 of y to the third. Now we have a case where there are no coefficients. We have logarithms with identical bases. Now we can apply the product property. So the sum of logs is equal to the logarithm of the product of the logarithmic arguments that you're adding. Okay, so if we apply that property here, we're going to have log base 4 of what are our logarithmic arguments in this case. Our logarithmic arguments are x squared and y to the third. Since we have a plus, this plus is going to turn into a product. So we have log base 4 of x squared times y to the third because we have a plus. And then we can rewrite that as log base 4 of x squared y cubed. And that, ladies and gentlemen, is the answer to question number 2. All right, let's take a look at another example, question 3. What if we were to condense the natural logarithm of 5 minus the natural logarithm of 2? So the solution is as follows. So we have the difference here of 2 logarithms base e, which basically means they have identical bases. So the quotient property will be applicable here. Whenever you have the difference of logarithms with identical base, is the same thing as finding the logarithm of the quotient of the logarithmic arguments. So in this particular case, we're going to have the natural logarithm of the first one before the minus goes in the numerator, 5 divided by the second, which is 2. Okay, so we're just basically dividing the logarithmic arguments. And this is the answer to question number 3. All right, let's take a look at another example, question 4. What if we have 2 times the natural logarithm of x minus 5 times the natural logarithm of y? Now in this case, we have coefficients which need to be taken care of. So let's rewrite the problem. 2 ln x minus 5 ln y. So the coefficients can be powered up to become the exponents of your logarithmic arguments using the power property of exponents. So that gives us the natural logarithm of x raised to the second power minus the natural logarithm of y raised to the fifth power. Okay, now we have identical bases, namely e. So we're going to now condense. Since we have minus, the difference of logarithms, as indicated earlier, is basically the quotient of the logarithmic arguments. So this minus is going to become a division in the regular world. So we have the natural logarithm of, the first one is the numerator, x squared divided by y to the fifth. ln of x squared over y to the fifth. And that is the answer to question number 4. All right, let's take a look at one more example before we have you do some practice problems. Question 5. What if you have log base 2 of y divided by 2 plus, or let's do minus, minus 3 log base 2 of x. Okay, so let's try this one out. So we see here that we have to do some work before we can apply the quotient property of logarithms. Okay, so what is the prep work that we have to do first in order to be able to apply the quotient property of logarithms? First things first, we need to get rid of this denominator and then this coefficient here. This denominator can be written as a coefficient, namely 1/2 log base 2 of y minus 3 log base 2 of x. Now, why did we write the denominator or the division as a coefficient? Well, it enables us to use the power property of logarithms to power it up. Okay, thus getting it out of the way. And then this 3 can also be powered up using the power property of logarithms. So we now have log base 2 of y raised to the 1/2 power minus log base 2 of x to the third. Okay, so something you have to remember is that one of the properties of exponents, special case of the nth root property, y to the 1/2 is basically the same thing as the square root of y. Okay, all right, so we can rewrite this as log base 2 of the square root of y minus log base 2 of x to the third power. Okay, now we are going to apply the quotient property. The logarithmic arguments are root y and x to the third. This minus is going to become a division. So we're going to have in condensed form log base 2 of the square root of y divided by x to the third. And that, ladies and gentlemen, is your final answer. Now, how well did you master the problems that we just went over? In order to demonstrate mastery, we'd like you to try out the following problems. So you just copy them down and do it. Pause the video because we are going to be displaying the answers momentarily, okay? So the instructions are the same. You're to condense the following. So question number 1, what if you have the natural logarithm of 3 minus the natural logarithm of 7? Number 2, what if you have log base 5 of 2 plus log base 5 of 3? Number 3, what if you have 5 log base 2 of y plus 3 log base 2 of z? Number 4, what if you have the natural logarithm of x over 3 minus 2 times the natural logarithm of y? So go ahead and pause the video at this time. I'd like you to try out these 4 problems. When you're done, you can click on the playback button and then you are going to see the answers displayed. Alright, so let's hope that you've had the chance to try the problems. The solutions to the problems are as follows. So the first one is the natural logarithm of 3 over 7. For number 2 is log base 5 of 6. For number 3 is log base 2 of y to the 5th power times z, or we don't have to put the dot product there, just multiply them. So y to the 5th power, z to the 3rd power. And then lastly, for number 4, we have the natural logarithm of, now you have x to the 1/3 here, which is basically the same thing as the cube root of x divided by y squared. Okay, so there goes your answers to questions 1 to 4. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your studies of logarithms, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments, just place it in the comment section below, and we'll be more than glad to assist you. Don't forget to subscribe to our channel for updates to other tutorials such as this. More resources and support tools can be found at mathgotserved.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.